We're going into Chapter 3. Chapter 3 is about symmetry. We're going to learn about symmetry and how that works in graphs and points, and how dare you leave stuff like that sitting in my room. All right. Chapter 3. Chapter 3. All right. The things that I have written on the board, all right, you can go into your book and you can take a look. There's different theorems and definitions within the book. I did it on here instead of me trying to handwrite it. I typed it. But these are important ones to know. Chapter 3. Well, you don't have to write it down. This is because I'm not going to test you specifically on what this definition is, all right, or what this theorem is. What I'm going to do is expect you to know what it means, all right. So if you take a look on page, what is it, 106, you'll see the point symmetry theorem. Then don't. All right. Two distinct points, P and P prime, are symmetric with respect to point M, if and only if M is a midpoint of P prime. So if I was to draw this, and I'd say this is P, and this here is P prime, M would be the midpoint. Okay? Point M is symmetric to its with respect to itself. What does symmetry mean? It means that the distance from here, that's pretty ugly, to here is the same. That means symmetry. All right? When we start working here, we're going to start working with graphs, and we're going to find points of symmetry within graphs. If we were to graph that, we'd find a point of symmetry in it. And what that means is, where it crosses, let's say, the x-axis here, it's the same distance here as it is here. All right? Now, the x-axis may not always be the point of symmetry. It may be a different line. You may have something that looks like this, and your point of symmetry is over here, and maybe it's where x equals 2. But you're going to learn how to find that point of symmetry when you do this. The graph of relation S is symmetric with respect to the origin if and only if a negative B, this coordinate, is a set of S whenever AB, that coordinate, is a set of S. What does this mean? It means if we take a function, f of x, all right, and for that function, we put in a negative x for it, it would be the same as saying that function of x is negative. That means it's symmetrical. All right? That's what it's saying here by this. Now, it doesn't mean that it's always a negative A, negative B compared to an AB. It could be AB and then a negative AB, meaning there's a symmetry there. Or it could be instead of this, it would be A negative B. And we could show symmetry there. Okay? So essentially what it says is if these two are within a set, then we can show that they're symmetric. Two distinct points, P and P prime, are symmetric with respect to a line L if and only if L is a perpendicular bisector between the line P and P prime. Now, that's what I showed you just a little bit ago. We've got a parabola here, and the line of symmetry, let's say, goes right here. Okay? If we can show that there's a perpendicular bisector to this, we look at these points here, and we find out there's a perpendicular bisector to it, then we can say that there's a point of symmetry. A point P is symmetric to itself with respect to line L if and only if P is on line L. All right? Which would be this one right here, which would be the vertex of this parabola. There would be your P. It's symmetric to itself. Those are the main ones in this section. In section 1 is knowing these three. The real key ones are going to be this one right here and this one right here. Those are going to be the main key. So if you can draw a perpendicular line or a line that cuts that equation, that function in half, you have found the line of symmetry. That would be line L. And if this is true, f of negative x equals a negative f of x, then it would be true. Now the last one on here that you need to know is going to be odd and even, or neither. Okay? And this will be part of your assignment when we do this. If you take a look on page 112 on the top, it talks about odd functions and it talks about even functions. Even functions will be symmetric to the y-axis. All right? So if I have something that goes like this, and I show that it's symmetric to the y-axis, then it's an even function. If it's symmetric to the x-axis, then it's an odd function. So this would be even. Make that x, and this would be odd. All right? If it's symmetric to neither one, then the answer for that is neither. But you need to find the symmetry between the two. All right? Let's take a look at some examples. Both no. Show me the function of that. Show me the function that would show an x on the graph. Yeah, you're not going to find either. Number 8 on page 113. Let's take a look. Page 113, number 8. Yeah, show me the function of that. And actually, you are right. That's both. If you want to know, you're good, Michael. All right. I wanted to take a look at. What's that? Circle, is it symmetric to the x-axis? Is it symmetric to the y-axis? You know, if it is, then it's both. Right? And in that case, it would be both. Let's take a look at one here. I'm going to put up f of x equals x to the fifth. Does this form symmetry? That's what we need to find out. So, if we take a look, if we put a negative out in front of these, all right, in other words, what we've done is we made it a negative f of x is equal to a negative x to the fifth. Is that the same as saying this? Yes, it is. That would be, putting in here, would be a negative x to the fifth. So we could say, and with this function right here, we could say that f of x, f of negative x equals a negative f of x, so they are symmetrical. What would a graph look like on that? That's what we're going to do. Desmos. Pretty easy. It's actually pretty easy. I don't want that. I don't want it squared. I don't want it to the fifth. There. Are they symmetrical? Because we could say as AB, right? AB is positive. We go, let's go 2. At this point, it'd be a negative. What's that? No, they're symmetrical to each other, but it's symmetrical this way. Okay? Doesn't mean that it's going to... What's that? Yeah, with respect to the origin. Origin is right there. 0, 0. Okay? Take a look at the top, 110. Actually, I'm going to leave this up because I'm going to graph this puppy then too. I'm going to graph it first. X to the 4th plus 3x squared plus 8. Is this symmetrical? Sure it is. What's it symmetrical to? Not the origin. Origin's down here. What's it symmetrical to? The y-axis. That's why I showed you. All right. Nope. So I guess you got to know how you're doing then, huh? All right. This should help you get going. What negative f of x equals to f negative x? Well, we just did. We just did. What is that on the board right now? Right here. On this board right now. I went over even and odd. Do I have to show you what an even and odd is? Even and odd. What is it symmetrical to? You graph it, you find out what it's symmetrical to. What is the line of origin? What is the line of symmetry on it? So if I take and I graph this. But you're teaching us how to do it with the calculator, but you said on the test we can't have a calculator. So how do we do it without a calculator? How have you ever graphed anything? I don't know, I never graphed anything. Really? X, Y. Dude, I can't even remember which one's X and which one's Y. So I guess you need to do some studying. I'm not getting mad. It's just kind of, there's your XY axis. Here's your XY. If I put 1 in for X, what's my F of X or my Y? 1. If I put 2 in for it, what is it? It's whatever 2 to the 5th is, right? If I put negative 1 in, what is it? Negative 1. If I put negative 2 in there, it's a negative 2 to the 5th. Well, of course you are. Yeah.